There are basic similarities to the operation of the trim and tilt system on every single outboard manufacturer, and even into most inboard-outboard trimming systems and some trim tab systems that you will find on a boat. They may look a little different, and they may have a different setup to the relays that you will find operating the system, but when it comes down to it, there are only two wires going to the actual trim unit itself. Now we'll take apart these two trim units just so you can get a picture of what goes on inside of the trim unit, how it works, and how you control it from the button. So this first trim unit is the trim unit that goes to a Mercury Verado. It's more of a one-of-a-kind type of unit compared to this other trim unit that goes to a Yamaha outboard. To get inside this unit, we've got to take out the top cap where we fill the unit at. Then inside you will find this pin here, and we can remove that pin. With that out, we can spin the casing here and then pull the housing off. It's important to note that we've already emptied out all the trim fluid that was inside of the unit before pulling this off, but with the housing off though, you will find the trim motor on the top of the mechanical pump portion that does the actual moving of the fluid in and out to move the trim rams in and out. So basically, depending on which way the electric motor is spinning, will determine which way this mechanical pump spins. And that will either move the fluid into the trim ram reservoirs, moving the rams out to push the engine up, or it will flow the fluid out of the rams and into the reservoir to allow the rams to come in and let the engine trim down. There's not much more to see inside of here. You can disassemble the rest of the unit if you would like to, but there's really just the check valves on the bottom of the unit here. And then the actual piston and rams, but there's really not much you can do to service these with the exception of just replacing the components that you want to. The other trim unit, which is more common on most other brands from Yamaha to Johnson's, Evinrude's, Suzuki's, Honda's, and other Mercury engines, works in the same fashion but has this exception here with the tilt ram in the middle. Now the electric motor on the top of the side of the unit here is what spins the mechanical pump that is found underneath it. That pump spins and moves the fluid either in or out in the same way that it does on the other pump. This design has a reservoir for the fluid to go into on the other side of the pump, whereas the Verado style just pushes the fluid into the center of the unit, and that is where its reservoir is found. This style uses tubes that route the fluid back and forth from the pump and the cylinders to the reservoir. The best way I can describe the reason for the three separate rams is because the trim is used while the boat is underway, so it requires the extra strength of the two rams opposed to the tilt, which is only used to raise the engine up out of the water, and requires less strength to only move the weight of the engine, not the added force of the engine while under power and pushing the boat. This is also the same for how a hydraulic trim tab pump operates, as well as a hydraulic jack plate operating as well. All of these systems use an electrical pump to spin a mechanical pump that has the strength to operate a heavy engine or the weight of a boat for trim tabs or a jack plate. Now when it comes to getting the power to operate these pumps, this requires more electricity to operate the pump, or it requires more amperage than most other electronics that you will find on the boat. Because it needs more amperage, it needs to use heavier gauge wire or a thicker wire to get this power. And instead of running this heavier gauge wire throughout the boat to your switches, these systems all use a system of relays to control this power. What this does is it allows the system to use smaller wires with less power running through them to control a large source of power that is used to operate the trim units. You'll notice that these pumps only have two wires going to them, which means there isn't a ground wire to the pump. Another side note though, that's not the case for the trim tab pumps or the jack plate systems. Those systems do have a third wire going to the pump that supplies the ground to the pump. But on the outboard side, the unit only has 2 wires, meaning that it is what is called a reverse polarity motor, meaning that when the voltage flows through the pump positively, it operates in one direction. Then when the voltage flows through the pump negatively, or in the opposite direction, it spins the pump backwards. Which is something that is important to understand about these systems, that they actually use the opposite relay as the ground circuit when they are running. Something that you can remember about these wire colors being blue and green is that if you supply positive power to the blue wire, it will raise the engine. If you supply positive power to the green wire, it will lower the engine. Most people remember these wire colors as being blue sky and green grass. Power to the blue wire brings the engine to the sky, and power to the green wire brings the engine to the grass. And this is actually all done through the relays. Most of the time, the relays aren't that expensive unless they are an all-in-one type like this Yamaha style relay. Then they can be pretty expensive, up into the $100 or a couple $100. When it comes to troubleshooting the system though, it's easier than you might think. The only thing you need is a voltage meter. I've got a digital multimeter, but anything that reads 12 volts DC will work. We just need to take the meter and make sure that there is voltage sitting at the high side of the relay. Then we can press the button and see if the voltage flows through to the other side. If it doesn't, then we need to just move over and make sure that voltage is being supplied to the relay on the low side or control side of the relay. If it's not, then we'll just work our way up the trim system, which is going to vary in style and sometimes in color depending on what brand you are working on. You'll work your way to the switch and just stop whenever you find out where the power is not being supplied from. It can be any of the items in the system, from the motor to the relays to the switches. There isn't really a "this is the most common part that fails" type of deal. All the parts do at some point in time. The quickest way to diagnose the system though is to just disconnect the pump and put power straight to the pump. If it doesn't move, you know it's the pump. If it does, then you just start with the relay and track the voltages through the system backwards. Now that you know all about the hydraulic trim systems on a boat, let us know if you've ever had to fix your trim unit and what the problem was in the comments section below. Don't forget to join the crew by subscribing, hitting that like button, and we'll see you next week.